Hello and welcome to the topic, what is science? In this lesson, we're going to talk about how do we measure in science. Specifically, we'll be learning about 1, why did scientists create the International System of Units? Number 2, what is the difference between accuracy and precision? And number 3, what are some tools used by scientists? So as always, let's begin with a few key vocabulary words. The first one is description. Now understand that description, when I describe it, it's going to be based on science. There are many different definitions for description. This is the one for science. And description in science is a spoken or written summary of what you observed during your experiments. An explanation is when you interpret those observations. What do you think they mean? That's an explanation. The International System of Units, or SI, is a system of measurement, how we measure different things, and it's accepted around the world. Everybody uses the same International System of Units. Accuracy is a description of how close a measurement is to an accepted or true value. All right? So, accuracy means you're right at what people believe is the accepted value of a solution. Whereas precision is a description of how similar or close measurements are to each other, right? So if you've taken many different measurements, are they all pretty close to each other? If so, then you have good precision. Another word is called significant digits. And that's the number of digits in a measurement that are known and are reliable. So, in this scenario, if you look at the number 7004.040200, all right? So, all non-zero digits are significant, all right? Now, zeros between non-zeros are significant. And trailing zeros to the right of the decimal are significant. And we're going to go over this in a little bit more detail later in the lesson, so you understand the difference between significant and not significant. So let's go ahead and begin our lesson. So we talked about a description, and that is, again, where you write down or you say what you observed in an experiment. And the explanation is when you kind of interpret what it is that you saw. You give what you think it means. Now, the big thing is this International System of Units. All right? Now imagine in Thailand, they measure land by rai. Some people measure it by square meters. Some people by kilometers. In America, we measure land by the acre or the square foot. So imagine all these people around the world, and they're all using different forms of measurement. How do, scientists, how do they talk to each other? How do they agree what, 1 rai versus 1 acre? How are they equal? So science came up with the International System of Units, or SI, that all scientists around the world use to communicate with each other about measurement. Now, all SI units are derived from 7 base units. You have length, which is the meter, mass, which is the kilogram, time, which is second, electric current, which is ampere, temperature, which is Kelvin, a substance amount, which is mole, and light intensity, which is candela. So those are all the units of measurement in SI. Now they also said, okay, let's base the system on multiples of 10. And the factors of 10 are represented by prefixes. So they go in front of these various measurements like meter or kilogram or second or ampere. So for example, you can either multiply or divide by a factor of 10 depending on where you're at. and it usually divides right about there. So for example, you can have decameter, hectometer, kilometer, megameter, or kilogram, megagram, hectogram, etc. And each one of those is a multiple of 10. All right? You also have centimeter, millimeter, micrometer, etc. And on and on. So let's get to our first key concept check. Why did scientists create the International System of Units, or what we call SI? Well, because different systems of measurement used in different parts of the world. Now, that causes confusion. So they wanted one system for all scientists. That's why it was important. So that way, one system, they can communicate their measurements to each other anywhere in the world. Now let's talk about accuracy and precision. So remember what I said, accuracy is how close a measurement is to the accepted or true value. All right? And precision is how similar measurements are to each other. So let's look at this example here. You can see it says it's got good precision, but poor accuracy. Because this is the true or accepted value, right? So it's very precise because everything is together. But it's not very true because it's very far away from what is the accepted value. Now this one, the next one, has good accuracy but poor precision. Because you can see it, most of them fall within that accepted or true area, but they're not bunched together, they're spread out. So that's not good precision. The next example, you don't have good precision and you don't have good accuracy. In other words, it's not within the true area and it's not close to each other or similar. So that's really bad. And the final example, you've got good precision and good accuracy. Not only are they all close to each other, but they're all true. Now let's look at another example. All right? This is student density and error data. And the accepted value for the density of sodium chloride is 21.7 grams per centimeters cubed. And then we're going to look at student A, B, and C, look at their measurements, because they measured it 3 times, 1, 2, 3, and then they took an average of all 3. All right, so let's look at student A's. Student A's have the best precision. Why? Because they're close to each other. You've got 23.4, 23.5, 23.4, so they're very, very bunched together. Now, are they accurate? No, because the accepted value is 21.7. So they were not good. This student had good precision, right? But poor accuracy. So now let's look at student C. Now student C is the most accurate. Why? Because if you look at the values they got, they're very close to the accepted value of 21.7. So this student had very good accuracy. And then finally, you have student B. Now student B, they are not precise or accurate. Look at this, 18.9, 27.2, 29.1. So their measurements are everywhere. And they are not close to 21.7. So again, student A was precise. Right? Student C was accurate because they were closest to 21.7. And student B, they weren't precise and they weren't accurate. So let's do a key concept check. How do accuracy and precision differ? How are they different? Well, remember that accuracy is a description of how close a measurement is to the accepted or true value. And precision is how similar or close measurements are to each other. In other words, accuracy looks at a target, and precision is other measurements. All right? So that's how they're different. Precision is based on other measurements. Are they very close together? And accuracy has a goal. It's looking at a specific value that you want. And how close did you come to that measurement? Now, remember that when we're measuring, no measuring tool provides perfect measurement. All right? All measurements are kind of a little off or a little uncertain. And that's where significant digits come in. This is where scientists get that. All right? Now remember, any zero before the decimal point, if it's just there on its own, like, sometimes you'll see people write 0.50 or 50 cents. That's not really needed. That's not really important. It doesn't have to be there. So those are not significant. All right? Zeros used only to locate the decimal point. Those are not significant. What is significant are all zeros between the non-zero numbers. Those are significant. Any non-zero number is significant. All right? Any number that's not zero, that's significant. And then also zeros at the end of a number, to the right of the decimal point. Those are significant. So this helps us to take very, very, very fine measurements, because that's what science wants. They want very fine measurements to say, okay, well, what's important and what's not important in this measurement? So we can go ahead and look at that. So remember, the rules for significant digits is all non-zero numbers are significant. 2, zeros between non-zero numbers are significant. 3, final zeros used after the decimal point are significant. Remember, after the decimal point. And zeros used solely for spacing the decimal point are not significant. Okay? Now, why do we use significant digits? Well, significant digits tell us how confident we are and how much we believe in our measurement. And if you look at this example, we know that 0.2 is a confirmed digit. It's a known digit. We know that 5 is a known digit. We know 5.2. What we're not really sure about is how it's just a little bit over the line of 0.2. So it may be around 0.03 centimeters. So it may be the measurement is 5.23. Now, we're kind of estimating that 0.3 because our tool, this ruler, it doesn't measure that part. It's not fine enough for us to find out, is it really 0.3? We would need a very, very specific tool or ruler to measure down to 0.03. So that leads us to our next key concept. Why should you use significant digits? Well, that's easy. They are the measurement that are known with reliability. How certain your measurements are. So that's why significant digits are important, because they mean that your measurement is reliable and you are certain of it. That's why we use significant digits. Now let's talk about scientific tools. All right. The first thing that I think we've talked before in other lessons is everybody should keep science journals. Science journals is where you record explanations, your plans for experiments, descriptions, observations, etc. It's kind of like a real journal, but for science. You also should understand the different tools that you're going to use in the lab. Now, one is going to be the triple beam balance. Now, or digital balance. Some people use digital balance. You know, the old style, you slide a little bar across, and the new one just has a digital readout, like a calculator. But remember that mass is measured by balance, and weight is measured by scale. All right? Now, there's a difference between mass and weight, and we're going to get into that. Because mass is measured by kilograms, and weight is measured by Newton. You also will use thermometers. Obviously, thermometers measure temperature, either in Celsius, which is probably what you will use, or in Fahrenheit, which is another way. There's also a third way that scientists measure temperature. You also will use some basic science equipment, like flask and beakers and petri dish and test tubes, etc. So you have test tubes, beakers, petri dishes, specimen jars, etc. All these will be used in your science class. Just be careful with them. And you also have a very common tool for measurement called a graduated cylinder. Now, graduated cylinder is used to measure the volume of liquid. So either liter or milliliter, etc. That's how we measure liquid in a science lab. And then, of course, everybody knows the tool, the microscope. Now, there are many different types of microscopes, and your school will have their own type. But basically, every microscope has one purpose, and we all know it's to observe small objects that we cannot see with our eyes. That's why we use microscopes. Now, if you don't have a microscope, or you don't need a microscope, simply just use a magnifying glass. All right? Now, the other thing is, remember that when you're looking at something on a microscope, like a compound light microscope, you have to place it on a little thin piece of glass, and we call that piece of glass a slide. So you have to place your specimen on this slide and then put it into the microscope. All right? So if the teacher says, "Where is your slide?" now you know what they're talking about. So, some other things that we do, but you probably won't be doing this anytime soon, is we use what they call dissecting tools. Dissecting tools are things like scalpels, scissors, etc. And this is when we're doing experiments on organic, whether it's a plant or an animal. Another term to remember is pipette. Pipette is a very small tube that we use to transfer liquid. It usually has a little bowl, and we bring up the liquid and then take the liquid and drop it into another by squeezing the bowl. And we call that instrument a pipette. And that's how we use to draw out, pick up, and transfer liquids from one container to another. You have pH paper. pH paper measures the acidity of a liquid substance. So your science lab will have those. You also have hot plates, and they are used to heat things. Be very careful with hot plates, or Bunsen burners is another one. Just be very careful, because anything that's hot obviously is dangerous. You also will use stopwatches to measure time. You will use spring scales maybe to measure weight or the amount of force on an object. So, another key concept check time. what are some tools used by scientists? Or let's say by life scientists, sorry. So what are some tools used by life sciences? Now remember, life sciences study life, plants, animals, etc. So maybe they would use magnifying glasses, or a microscope, or dissecting tools such as scalpel, scissors, etc. I mean, there's many different tools they can use. But obviously, if you're studying life, like you'll go out and look at a bug, maybe you're using that magnifying glass, right? Or if you're looking at a cell, you're going to get a slide and put it in the microscope. Or a very common experiment for students would be dissecting frogs. And for that, you would need a scalpel. So you're going to come in contact with many different kinds of science equipment. And you're going to have this list to study. So anything that you want to learn about, pipettes, droppers, etc., syringes, spatulas, tongs, petri dishes, crucibles, mortar, and pestle, it's all going to be there for you to study. Simply look at your e-learning book. So in summary, remember, precision is a description of how similar or close measurements are to each other. Accuracy is about the true value. What is the value we are looking for? And that is accuracy. And you can have good precision and good accuracy. You can have poor precision and poor accuracy. You can have good precision and poor accuracy, etc. But your target, what you really want, is all your measurements close to each other or precise, and all your measurements close to the accepted value. Scientists around the world use this International System of Units, or SI, to measure many different things so that when they communicate, they know they're talking about the same thing. And we use a lot of different tools in our science experiments, and these tools help to make our science experiments easier, more accurate, and more repeatable. Congratulations, you're done with the lesson of how do we measure in science. I hope you enjoyed it, and we'll see you in the next lesson.